My name is Steve Anderson, and I'm the Director for Outside Line Construction Curriculum and Training for the NJTC. I'm about ready to show you one of the items that we use in our online curriculum. It's a transformer simulator that was developed by 3D Internet, a company out of Canada that we use for several of our programs. And we found that a lot of the instructors and students really get a lot out of the simulator. So I'm going to demonstrate it to you, and I hope you enjoy the demonstration. Okay, we're going to hit continue. Next, we hit start a new configuration, and that brings us up to our line configuration section. Using our lab manual, we can see that we're going to hit a delta on the top. We're going to insert the primary voltage, which is 6,900 volts. Now I notice 6,900 volts is not loaded in here, so I'm going to have to customize the voltage. And I'm going to put 69. I'm going to add that to the list. And we now have 6,900 volts. So we back up one. There it is. And we want to note that this is the voltage, is the source voltage from the pole or the underground system. That's where we came up with the primary being 6,900 volts. The number of primary lines will be 3. We're going to do clockwise direction, which is clicked on. Secondary, we want 120/208. Choose the number of secondary lines will be 4. The automatic secondary line labels should be disabled, which they are. We're going to check the grounded neutral. We want the schematic view. We want to make sure that the explosion option is enabled just in case we mess up on this thing. And then we're going to hit continue. Now we have our option of pole 1 or pole 2. We're going to select pole 1. If we were doing more than one set of banks, we could actually do both of them, but this gives us our schematic view. Next, we're going to go through and fill out the transformer configuration. The number of cutouts on the transformer on the primary side would be 3. We want the number of transformers that will be used in this service is also 3. All the transformers are configured the same, and yes, they are. The number of primary bushings will be 2. The number of secondary bushings will be 3. This will be a parallel internal winding connection. We also want to make sure that it's a subtractive type transformer. And again, our primary voltage is 6,900 volts. And our secondary voltage is 120/208. Whoops, there it is right there. And we're going to confirm. We look it over, make sure everything's fine. That's the connection we have. And now we're ready to go through and start connecting the transformers in the schematic view. We could also go through, if we wanted to do a field view, and hook it up in the field, if that's what you're more comfortable with. But in the classroom, most of the time we'll use the schematic view. I hit connect up on top up here, and now I'm going to go through and connect this into a Y connection. We've got our trusty lab manual right here. Not only does it give you the step-by-step instructions on how to hook it up, but we've also got screenshots. So it'll show you, where the bushing should be connected to which phase, and how to go through and check it with the phasing sticks, whether it's energized, so the instructor will know exactly what it should look like before he goes through and hooks it up. Our delta connection. Okay, we want to energize this just to check to make sure that we've got the right voltage on the primary side. These arrows at the fuses indicate that the transformers are energized. The transformer is energized. We're going to take our phase stick, and if you look down here at the meter, we've got 6.9, which would be 6,900 volts. That's exactly what we're looking for. All right, so let's go back to connect. We're going to now connect the secondary, which is in a Y configuration. And I want to be sure to ground this. Okay. Let's energize it and see what happens. Oh my goodness. I better reevaluate what I just connected because it looks like I've got a smoke transformer there. Okay, it'll go back to the schematic view. And if I look at my vector diagram, it is just going crazy here. So I've obviously done something wrong. So why don't I go through, I'm going to remove some of these wires. I want to look at the schematic view of this. Let's get this back on the paper here. Oh yeah, oh I can see it now. This was supposed to be a Y connection. Look what I've done. I've totally messed it up. So let's go through and remove some of these wires. And we'll connect everything the right way this time. And let's see if we can get it where it will show 12208. Got this to A. Y connection, we're going to have a center tap. Energize. That's much better. Much better. We'll take the voltmeter, and again, we'll check from A phase. Again, the customer needs a 12208 service there. We have 208 from phase to phase, and we do have 120 volts from phase to neutral. 120, 208. So we know we've got the right connection and the customer has got everything that he needs and we've done a good job. And you can see how the transformer simulator is a terrific tool to teach the students how to go through and hook up a transformer. You know, in the past, we would have them sit at a table with a two-dimensional piece of paper with some windings and some lines drawn on it and have them draw lines between the windings and the line to show them how they hook it up. And they really never knew if it was going to work or not. Now they can sit down, take those windings that they drew on that piece of paper, come to the simulator, connect the wires, energize them, see how well they've done, and then take a voltmeter and check the voltage to make sure they've done the right way. So this is just a terrific tool for apprentice, or it's a great tool to bring journeymen back into the classroom on a refresher course if they haven't worked with transformers in a while.